Okay, welcome back. So now we want to get into the computer playing against us, or we playing against the computer. And first of all, I want to make a function that prints out the board in a nicer form. So APL has a very nice way where we can use a matrix to index this list of characters, and since it has 0, 1 and 2, we have to add 1 to get the correct indices 1, 2 and 3 here. And we could use it this way, but I would like to have spaces in here, and APL has this for this format function, which gives us this space between A stands for alpha numerically, I believe. So we could call this pretty print, for example, and get again this nice form here. Let's put it directly here in our source code. So now we can pretty print the board just like this. Let's test it. Nice. Okay. So now let's care for the real program. So we need a main loop where we make a move, and then the computer makes a move, and in between we print the board and add stones. Okay, so let's say computer is always 1, human is 1, and computer is 2, and human always starts, and A is the column. So how do we get input? Well, it's easy. So this gives us a character input, and now let's make this a local variable, maybe also the board, and then we need to convert this into a number, and we can do it this way. Let's test this. So here we play the role of the computer ourselves. Let's test if this works. So let's say 4. Okay. Maybe like this. Yes. So 3, 3, 2, 1. Okay. So this works so far. What we need still is a way to abort this procedure. So let's say if we enter 0, we leave this loop and yeah, and for the computer we need a way now to call our point function. Okay, so it should try all 7 columns. Let's say add board and a vector of 7. Of 1 to 7. And return this to a list of boards where the stone has been inserted in this column. Okay, so this iota 7 gives just a list of 1 to 7, and for each one of them, like this, apply this function. So it would call add board 1, add board in column 1 stone 2, add board in column 2 stone 2, and so on, and then return a list with these boards. And what we can do now with this list is again the same. For each board of this list we calculate the points, and this gives us a list of points for this move. And just let's display this list. And then what we would do, of course, is take the maximum and the maximum of these points, and throw the stone in this column. So we still need to get our column from this, and this is of course the index in this list of values where the maximum occurs for the first time. So it could happen even that some columns have the same value. So but this index construction still gives the first occurrence. Okay, so the leftmost. So let's try if this works. We still have this board. Okay, 0 aborts. So this works already. This was only a test. This is how it should look. Okay, so this seems to work. We have thrown a stone in column 4. It has applied the point function for all the columns, and the middle one has the most points, namely 3. The others have negative points, and it has thrown the stone in there. And now we are at the move again, and again it has applied the points, and now of course this doesn't work yet. This isn't working. And there's another problem that we haven't encountered yet. What happens if a column is full? So let's throw in here. This gives an index error. Okay. So what we could do next is care for a won or lost situation, and maybe before that we should care for a situation where a column is full. Okay, so let's get rid of that. So instead of a list of all the moves here, what we trust that the human player doesn't throw a stone in a full column. Okay, so we are not going to test that. But here for the computer, we have to take care that not all the 7 columns are taken into account, but only the valid ones. So we are going to write a small function, valid moves, for the board. So this should give us a list of all the valid columns of the board. And we already had this valid moves. We had this here where we have calculated the height. The height of a column, only that now we would have to do this for each column, and I'm gonna make a shortcut here, sorry.